So now let's try a simple odds problem ourselves. One person is selected at random from a class of 12 males and 19 females. Find the odds against selecting part A, a female, or part B, a male. Now in the world of probability, we would have to add the males and the females together to get a total. But remember, with odds, we're doing part compared to another part. So when you're finding the odds against something, you're going to start with the part that's not that something. So part A says find the odds against selecting a female, which means we're going to find the numbers that are not female. And I like writing it with words first. So I'm writing not female, colon, and then we compare it to the ones that are female. And when you write it with the words, not only does it help you know where the not goes. When it's against, you're starting with the not. If it was in favor, you would start with the females. But then it makes it really obvious your numbers. How many of them were not female? Well, that would be the 12 male. And then how many were female? 19. So your answer is simply 12 colon 19, or 12 to 19. Those are the odds against selecting a female. Similarly, for part B, the odds against selecting a male, we start with not male, because the odds were against. You're starting with the ones who are not what you're looking for, and then colon, the ones that are male. So again, if you look back at our data, how many were not male? Well, that would have been the 19 females, and how many are male? 12. So this ends up being the same ratio, but flipped around, so 19 to 12. Remember, we don't write them as a fraction because neither one of those numbers is the total. In fact, if we add them together, that's when we get the total. Then the second half of the slide says, what are the odds in favor of picking a jack out of a standard deck of cards? So if you don't remember your deck of cards, you can go back to the slide that has them all written out. This time it says odds in favor. And so if you're writing in words, that means you're going to start with how many jacks are there, colon, how many are not jacks. And again, I like to write it with words. I like to see the thing we're looking for and then it's not, so that you can see the two obvious. If you go back to your deck of cards, there are 4 of every type, so 4 jacks. And how many are not jacks? If you need to remember, there are 52 cards, so 52 minus 4 gives us 48. There are 48 cards that are not jacks. So what are the odds in favor of picking a jack? 4 to 48. However, just like with a fraction, even though we're not writing it as a fraction, just like with a fraction, we also have to reduce. So if we divide both of those numbers by 4, 4 divided by 4 is 1, 48 divided by 4 is 12, and that's going to be our answer. The odds in favor of picking a jack out of a standard deck of cards is 1 to 12. There's one chance you get a jack for every 12 chances you do not get a jack.